Hi, I'm Micheal Woods, and this is my personal project, which is an AI emotion detection program that can detect people's emotions using Streamlit and Python. So first, let's see how this program works. So it opens up with the title and just a simple message. And right below it, here's an upload image button. So I'm going to upload an image real quick. Alright, so when I've uploaded this image, it shows the image right here on the screen. And it has the predicted emotion, which the AI detected as sad. And here is my model score chart for each emotion. So here it shows all the 5 emotions that it's possible to detect, and it shows the scores, or basically the percentage that it had for each emotion. And as you see from this graph, you can see that sad had the highest score. And finally, this program ends with the message that just saying that, of course, the motion detection model isn't perfect, and it always won't be like 100% accurate, but the AI, of course, will continue to improve. And I gave credits to the Streamlit motion detection model, which provided the libraries and some necessary code, as well as the images needed to train the model. So how does this program really work? Let's go straight into the code. So opening up my Streamlit code here, scrolling up to the top. So this first chunk here is the libraries. So right here says install Streamlit, install Pinegrok, and this downloads the emotion detection model for Streamlit. So all these three were very crucial for this program to work, because Streamlit is the website that it runs on. As you can see, it's on Streamlit, as you can see from the bar here. And Pinegrok is basically the server, or in their terminology, a tunnel that allows me to access this website. And the emotion detection model for Streamlit, this was really helpful because it provided all the images, as I previously said, to train the model, because training the model is something that's very necessary for this program to work. Lastly, all these imports here, these 5 imports, these are all very beneficial because it helps the AI algorithm to work as intended. Moving here, so this, as I stated here, this is used to reset the code. So this writes a file called app.py, which you can see right here. All the code is already in app.py. And import Streamlit, which I've already reiterated earlier. This loads the Streamlit thing. And if you click on this, it resets all the code. I'm not going to do that right now because I don't want to really reset all my code. So this says title and description of the app. So if I were to reset this and I loaded up the website, what would show is it would just say title and then description of the app, because that's what it says right here. And of course, as it says here, this would overwrite app.py. So this would all be deleted if I run this, and then it would just have these 2 lines on it. Next, moving on to this chunk, this is the Pinegrok stuff. So basically, this is a tunnel that allows the website to be accessed, as I've previously said. So it opens a URL and ngrok port, and it basically runs. And when you run it, it loads an ngrok tunnel, as you can see right here, and it says that you can now view the Streamlit app. If I click on this, which I'm not going to click on right now, when I click on this, it directly takes me to this program. Very convenient. So let's move on to the actual code now. Starting with this first chunk here, this is in accordance with this chunk here. This is basically all the stuff that I need for the emotion detection, like the actual AI aspect of it to work. So in the first line, the first real line here, I just define the emotions. There's 5 emotions here: angry, happy, sad, surprised, and neutral. And these are all the emotions that the AI can detect. Starting with the first chunk, this is basically the intro, I guess, for all this stuff. So it creates a title here, which I called Michael's Marvelous Emotion Detector, and a header. This program created by me, it used the power of AI to detect emotions and upload a picture to try it out. And then right here, I loaded the emotion detection model. I can go over the emotion detection model later, but this essentially is a big part of the code that was really helpful. And then right here, which I defined as F, this is like an upload image button, I guess. So if we go back onto the main code, we can see this here with the title, the header, and then the upload image button. So this is the nitty-gritty part of this AI program. There's quite a lot here, and it's a little bit complicated, but I'll do my best to explain it. So basically, I defined f here as the upload image. So basically, when the image is uploaded, it extracts and displays the image as I've stated here. So this part explores how the computer reads an image. There's something called convolutional neural networks. So first, in order to read the image, the computer first breaks this image down that we've uploaded into 3 channels of color, that being red, green, and blue. This says blue, green, and red here, but it's essentially the exact same thing. And these are called channels, as is stated here. And these color channels are mapped to the image's pixel. The computer then it recognizes the value associated with each pixel, and then it determines the overall size of the image. So in order to make this convolutional neural network practical, it has to fit within a 48 by 48 by 3 pixel frame. 48 represents length, 48 represents width, and then 3 represents the green, red, and blue, or as stated here, blue, green, and red indicators. It's like a layer. And this is for practicality because having too many pixels leads to overfitting. So just a brief overview of convolutional neural networks. They're made up of neuron layers that evaluate an image. And they're made up of neurons with learnable weights and biases. Each neuron, it essentially receives several inputs, takes a weighted sum over them, and passes it through an activation function and responds with an output. So in our program, an image of a person is fed into the program, and factors such as the mouth position and the size of the eyes are neurons that influence the overall emotion that is predicted. So why we have to have this set as a 48 by 48 by 3? This is just for practicality, as I've stated earlier. So having something like a 200 by 200 by 3, it results in 12,000 neurons for just the first layer of this network. As I've stated, a convolutional neural network is made up of many layers, and having as many as 12,000 in the first layer is just too much. It's just simply too much. And this is all the stuff that essentially prepares the image, like it says right here. This runs the model. That's pretty simple. It runs the model. Right here, this is the part. Oh, I forgot to say this. When it says run the model, this uses the. Where is it? It's the emotion detection thing as provided here. Emotion detection model for a streamlet. So this is quite necessary to have here because it's very, very difficult to write this all by myself because I don't have access to hundreds of thousands of images that train the AI. Because in order for an AI to detect patterns in people's emotions, you really need a lot of images to start to see similarities in certain emotions. For example, there's quite a defining image of what makes a person look happy, from their smile that they have and just their grin. So for a computer to really notice that pattern, you need a lot of images. And obviously I don't have access to hundreds of thousands of images, so I had to use this emotion detection model. This also uses some of the main convolutional neural networks that define some of the neurons that I've stated that help detect what the emotion is in the image, such as the size of the eyes or the mouth position and other things like that. And this was really very helpful because without this emotion detection model, I probably wouldn't have been able to create this program. Next, this part prints the results and the plot score. What I mean by plot score, it's basically the graph from right here that shows all the statistics for the emotions, basically. So first, it writes the predicted emotion is the emotion based on the scores, which the AI concluded as sad for this picture. So this creates a data frame. A data frame is what they call essentially a bar graph. Right here, have emotions and scores, as it states right here, emotions and scores. And of course, this graph has a nice title, which I called Micheal's Marvelous Emotion Detectors Model Score Chart for each emotion. And all the scores are written here. Scores.flatten essentially just shows all the scores. And then the last two lines, it's just two quick messages at the bottom saying that, of course, this emotion detection model is not perfect. These predictions will not always be 100% accurate, but the AI will continue to improve, and thank you for trying out this program. And of course, I gave credit to the Streamlit emotion detection model, which provided libraries and some necessary code. And without this model, I don't think this project could have been possible. And yes, this is my personal project, which is an AI motion detection program. Thank you.